Welcome to Scratch tutorial lesson number 6. We continue to introduce important block groups and focus here on values and operators. We clearly have already used some of these blocks and had a brief overview in lesson number 2, but it is time now to address them in detail. Remember how we always say that any of the oval-shaped objects can be edited and we can change their values. See, any of these blocks have such objects which are their inputs, and the input's oval shape gives us a hint that only values can be input here. These oval-shaped objects have some information stored in them, and that does not have to be just a number. It can also be some text. For instance, right here at the bottom, this is a value, right? It's oval-shaped, but this is a word. This is a text value that is made up of two joined words, right here. Also, value can be a logical expression, true or false, but we'll get to the logical expressions in a moment. So all the objects that are oval, they're called values, and they exist across different block groups. So let's take a quick look here. In the motion group, we need to scroll all the way to the bottom to find three oval-shaped objects, x and y position and direction of a sprite. So let's quickly demonstrate how we can use any of these information, right, in our code. Let's say that we want to orient our sprite, our Skratchko, to some random orientation, but then that Skratchko also tells us what that orientation is. So we'll go to the events, use our green flag to start the action. Then the Skratchko needs to be oriented, right? So we're going to go here, point in the direction. We're going to make it a little bit more interesting by picking the random direction, say between 0 and 180. That's why he needs to tell us what that is. And then we're going to go to looks, right? And we're going to let our sprite tell us for say 3 seconds what is that orientation, right? So to do that, we need to pick up our value for the direction, and we replace this hello with the direction, right? So now when we click on the green flag, sprite's gonna rotate in some direction and tell us what it is, right? So 92 degrees, right? 20 degrees, 98 degrees. But maybe just making this statement is not enough. Maybe we want to add some words to it besides just the number, right? So we just saw in the operators right here that we can join two words, right? So let's say he can start with pointing at, and then second word would be this direction, right? So instead of just stating the direction, now we can say pointing at that direction, right? So if we click now, pointing at 65, 84, or maybe for another moment we can want to just declare what that is. So that is degrees, right? X degrees. So in that case, we can use this as the first word, right? Replace apple. So this is now pointing at X direction. And then we want to follow with degrees, right? Now it's a fuller statement, and it is very clear what is the sprite trying to tell us, right? So click here, pointing at 87 degrees, right, and so on. Okay, so that was in the motion group. In the next group, in the looks, right, we can also find values if we scroll all the way to the bottom, and there is a costume number, backdrop number, when we have more costumes and backdrops, and also the size of the sprite, right? So for the size of the sprite, we're going to go back to our old example of inflating a balloon. So let's import the balloon right here. And if you remember, what we were doing at the time, we were inflating a balloon by blowing on the microphone. Here we want to make a different point, so let's just simply use this green flag. So when the flag is clicked, balloon is going to be inflating. So if we go back to what we used to do before, change size by say 10 or whatever every time we click, the balloon would keep inflating, right? So let's check. If we do this, balloon inflates, but we can notice that it always inflates the same. So this is not really that realistic, because we know as the balloon grows bigger, it's going to be expanding slower. So it's going to be adding volume at a slower rate as it grows bigger, as its size is larger. So how do we make this a little bit more, real, believable, right? So we can say that the size is changed inversely proportional to the size, right? So what we can do, we can go to operators and say, okay, maybe we do this. We're gonna say that the size is gonna change inversely proportional to the current size, which is right here. This is the value for the size. And instead of changing by 10, we're going to be changing by this now changing parameter, right? Depending on the size. So let's see what happens now as we demonstrate this. So first it grows, like a larger pace, but then as it grows bigger and bigger, the pace actually slows down, so it begins to look more realistic, as if we were inflating the balloon, right? So this is one example of how we can use our values in the looks group, right? In the next group, in the sound, you get the pattern by now. We need to go all the way to the bottom to find some values, and the only one is the volume of the sound, right? Now, for the next two, events and control, let's ask ourselves first, do we think that the stored value can act as an event or control? Not really. Values can certainly be used for some decisions to be made, but they cannot represent an event or control. So as we keep scrolling, we won't find any other value until we get to the sensing group right here. But then, surprise, we have quite a few values right in the sensing group, right? So we can see what is the position of the mouse. We can see what is the loudness. Timer, we use the timer, so let's remind ourselves. Timer, every time we start a project, timer starts ticking from 0, and we can at any instance go to this timer and figure out how long has passed since the beginning. So we have a time reference if we need it in our code. Also, you see we have some backdrop of the stage. We can find also time reference to a year or days, which also may be useful, and if there's a username. But what we really want to focus here, let's take a look at this one that looks a little bit different, right? So there is a value answer right below the action block that asks a question. So we can ask the user a question, get an answer, and then use that answer in our project. So we can interact with the user in that way, and the value we get back from the user, this answer is called the return value, as we get it in return to our question, right? So let's quickly demonstrate this one, because this one is really a little bit unique. So let's actually go back to our sprite. We can hide the balloon, we don't need it right now. And if we want, we can go back to 90 degrees here. So go to our usual orientation for the sprite, although it really doesn't matter. So what we want to do when we click the flag this time, we're going to ask a question, but the question is going to be which sound to play. So which sound to play, and then when we get the answer to that question, then we're going to play that sound. So let's go to sound, and we're going to play a sound, but right, instead of playing this fixed sound, what we're going to do, we're going to go into sensing, right, and we're going to pick this answer that goes with the question. So this answer is going to be decide which sound to play, right? And since this is new, let's see what happens, right? When we click on the green flag, we're going to get a question which sound to play. Before we can execute this, I just want to quickly show that we have two sounds to play, and they're named as 1 and 2, so that we can pick 1 or 2, right? But in the code, we don't know yet what is going to be played. We're going to be asking this question, so we do this now, right? So ask a question, which sound to play? And we answer, say, 2, hit a return, and you see the sound number 2 plays. So this is the interactive way to essentially interact, right, with the user, and it is very useful in that sense. All right, so finally we got now down to operators, right? And they're important, as we already seen, in performing different algebraic operations, right? We have here typical addition, subtraction, division, multiplications, and so on. And some of them result also in values, because obviously they are oval shaped themselves. So when we add two numbers, it's going to be value again, right? So there's nothing new here. We've seen this before. However, there is another group that we have not used so far, which takes the shape of some extended hexagon, right here. These are what was mentioned at the beginning of this lesson, logic or Boolean variables that have only two possible values, true or false. So whenever you see this hexagonal shape, it carries either a true or false statement. These are the most important statements in decision making, and we will see in the next lesson how we use them for that purpose in the control blocks right here. Okay. In addition, there are also Boolean algebraic operators and, or, and not, which themselves result in Boolean true or false, as also indicated by their shape. So what do, right? The operator AND takes into consideration two Boolean statements, right? So let's say we're gonna bring this one, and we can bring the same one here. So what happens now? Let's say that first one is 50 equals 50, right? So this is going to result in a true. And this one, we're going to say 5 equals 50. So we have true and false. When they're connected by the operator AND, they result in false. The only way that AND operator is going to result in true is only if both of them are true. So now we make them both true, and when we test this, click here, we're going to get a true statement, right? As for the OR operator, for that one, it is sufficient that only one statement of these two is true. So if only one or both, right? It can be only one is sufficient, but it can be both. It's true. So this one's going to be false only when both statements are false. And obviously not is just a negation. So not of true is going to be false, and not of false is going to be true, right? So relatively simple but very powerful, as we will see in the control blocks in the next lesson. And now to close this lesson, we will reveal a secret related to Boolean values. Besides carrying true and false statements, they in parallel also carry number 1 as true and number 0 as false. Now, does that mean that we can insert them into algebraic operators, say here in addition, right? Since they carry 0 and 1, can we insert them here, right? But then they're different shapes, right? We have this one, which is a Boolean value, in this case true, and it's a different shape than what is expected here. So, right, we can't fit it, we cannot fit hexagon into an oval, right? Wrong in this case. This is an exception, and they're not accidentally of the same color. So see, if we bring this here, it fits, although it's a different shape. So they're not accidentally both green, right? And just to test it, let's say this is 15, right? So we adding this Boolean to 15. In this case, this is true, so it should be 1. When we execute this, should be 15 plus 1 equals 16. So let's check. 16, right? If we make this one false, we change this to 5 equal 15. So this is now 0 because it is false. 15 plus 0 is going to give us 15, right? So test it here, right there. All right, so we now close this lesson by sharing this little secret of Scratch.